This is Sivakumar, 12th Standard Business Mathematics and Statistics, Chapter number 1, Exercise 1.1, Continuation. In Exercise 1.1, problem number 1, so far we have completed 7 subdivision. This is the last subdivision in problem number 1. We are going to find the rank of the matrix by row echelon method. What method? Row echelon method. Actually, the rank can be determined in two methods. One is a minor method, another one is a row echelon method. Particularly if you are given a matrix, a rectangular matrix, better to go for row echelon method. That will be more easier than minor method. First write order of A, 3 rows, 4 columns. 3 rows, 4 columns. Therefore, rank of A, which is less than or equal to minimum of 3 and 4. Therefore, rank of A less than or equal to minimum of 3 and 4, that is 3 only, right? 3. So, the rank can be 3 or 2 or even 1. Now put equivalent. Don't put equal sign, equivalent. In this method, first you have to find out the non-zero element, first non-zero element in the first row. This is the first non-zero element in the first row, under which we have two numbers, both the numbers to be changed to 0 using this number. Okay, so that write the first row, no change the first row as it is, R1. Now R2 implies, since we have minus 2, if it is plus 2, minus 2 plus 2 will be getting 0. For getting plus 2, what to do? 1 should be multiplied by 2. So R2 plus 2R1. In rough work, listen carefully. I do the calculation in rough work. Look at that, R2 plus 2R1. R2 as it is, R2 here it is. Minus 2, 4, minus 1, minus 3. Each and every element of R1 should be multiplied by 2. Multiplied by 2. 2 ones are 2. 2 into minus 2, minus 4. 2 3s are 6. 2 4s are 8. Now, minus 2 plus 2, 0, 4 minus 4, 0, minus 1 plus 6, 5, minus 3 plus 8, also 5, 0, 0, 5, 5, right over here, 0, 0, 5, 5. Next, this element, even this number has to be changed to 0 using the number 1. So you can direct addition. Look at that, minus 1 plus 1, 0. Very easy. R3 implies R3 plus R1. No change of sign. So R3 plus R1. So R3, for your reference, I do the calculation over here. Minus 1, 2, 7, 6 plus R1 means no change of sign. Right as it is. 1 minus 2, 3, 4. 1 minus 2, 3, 4. Minus 1 plus 1, 0, 2 minus 2, 0, 7 plus 3, 10, 6 plus 4, also 10, 0, 0, 10, 10, 0, 0, 10, 10. Before proceeding, can we divide that second row element by 5? Third row element, each and every element by 10. That will be easy for you, so that I am retaining first row as it is. R2 implies 1 by 5 times R2. That means I am dividing each and every element by 5, or even we can say each and every element should be multiplied by 1 by 5. See, 0 into 1 by 5 is 0. 0 into 1 by 5 is 0. 5 into 1 by 5, that is equal to 1 only, no? 5 into 1 by 5, 5 get cancelled, 1. Like that, again 5 into 1 by 5, that is equal to 1. Similarly, R3 here, 0, 0, 10, 10. So each and every element can be divided by 10, or even you can write 1 by 10 into R3. That means 1 by 10 into 0, 0, 1 by 10 into 0, 0, 1 by 10 into 10. 1 by 10 into 10, that is equal to 1. Okay, write 1. Again 1 by 10 into 10, that is also 1. Put equivalent matrix. R1 no change. Look at that. R1 1 minus 2 3 4. 1 minus 2 3 4. Even R2 no change. 0 0 1 1. Now look at that matrix. Even second row, which one is the first non-zero element? This is the first non-zero element, under which there is one number that has to be changed to 0. So that R3 implies here 1, here also 1. Direct subtraction. 1 minus 1 will be getting 0. So that R3 implies R3 minus R2. I do the calculation here. R3 please 0, 0, 1, 1. R2 should be multiplied by minus 1. R2 should be multiplied by minus 1. Here is R2. Multiply by minus 1. 0, 0, minus 1, minus 1. Right here 0, 0, minus 1, minus 1. 0, 0, 1 minus 1, 0, 1 minus 1, 0. So all zeros. It is in echelon form. Now we can write the rank. Therefore, rank of A equals, can count the number of non-zero rows. Here it is a non-zero row. It is also a non-zero row because we have two non-zero elements. Here this is a zero row because all the elements are 0. Now count the number of non-zero rows. Here one non-zero row, here one non-zero row, totally 2. So rank of A, that is equal to 2, since it has 2 non-zero rows. I hope that you have understood this concept. If you have any doubt over this method, make a call. I will be clearing the doubts. Thank you, children. This is Sivakumar, 12th Standard Business Mathematics and Statistics. Chapter number 1. In chapter number 1, exercise 1.1, you have completed problem numbers 1, 2 and 3. Now problem number 4. Solving the system of equations by rank method. You are given 3 equations with the 3 unknowns, x, y and z. Write the equations in matrix form. Five, 3 and 7. X, Y, Z coefficients 5, 3, 7. The first row. Second row 3, 2, 2. 26 and 2. And third row 7, 2, 10. 7, 2 and 10. Here X, Y, Z 4, 9, 5 in the right hand side. Consider the first matrix as A, this one capital X, right hand side matrix as B. Now augmented matrix. Two matrices together, A and B. First A matrix 5, 3, 7, 3, 26, 2, 7, 2 and 10. Then followed by the matrix B 4, 9, 5. We have to change this equation into echelon form. For that, you have to consider the first non-zero element. This is the first non-zero element in the first row. below which two numbers are there, 3 and 7, both to be considered, both to be converted into zeros, right? Put equivalent, write the first row as it is, 5, 3, 7 and 4. First row no change at all. Second row we have 3, there 5, right? With the help of that number only it has to be changed to 0. So that I am multiplying 3 by 5 and 5 by 3, right? Then only can get both 15. That means R2 implies 5 times R2 minus 3 times R1. I do it in rough work. Five R2 means multiply the second row by 5. 5 3s are 15. Then 5 26 are 130. 5 2s are 10. 5 9s are 45. Multiply odd one by minus 3. Minus 3 into 5 minus 15. Minus 3 into 3 minus 9. Minus 3 into 7 minus 21. Minus 3 into 4 minus 12. Have to subtract. You will be getting 0, 121, minus 11 and 33. Minus 11 and 33. Zero, 121, minus 11 and 33. Now R3, it has to be changed to 0 with the help of that number. Here 5, here 7. So that this number 7 should be multiplied by 5. 5 R3 minus, it should be multiplied by 7. 7 R1. So multiply R3 by 5. 5 7s are 35. 5 2s are 10. 5 10s are 50. 5 5s are 25. Multiply R1 by minus 7. Minus 7 into 5 minus 35. Minus 7 into 3 minus 21. Minus 7 into 7 minus 49. Minus 7 into 4 minus 28. Here 0, minus 11, 1 and minus 3. 0, minus 11, 1, minus 3. Put equivalent matrix 5, 3, 7, 4. First row and second row as it is. Before that, write the first row no change at all. Look at that second row. Look at the elements 121, 11 and 33. Each and every number can be divided by 11. So that R2 implies I am dividing R2 by 11. Divide 120 divided by 11 is 11. Minus 11 by 11 is minus 1. 33 by 11 is 3. And write R3 as it is. 0, minus 11, 1 and minus 3. Again equivalent matrix. Write first row and second row as it is. R1 and R2 no change. Now R3 implies, for making this element, because in second row this is the first non-zero number, with the help of that number it has to be changed to 0. So that if we add directly we will be getting 0, correct? 11 minus 11, 0. So that R3 implies R3 plus R2. Without changing the sign you have to put plus symbol. See, R3 plus R2 you can directly add. 0 plus 0, 0, minus 11 plus 11, 0, 1 minus 1, 0, minus 3 plus 3, 0. Now it is in echelon form. Now you have tried the rank of AB as well as rank of A. Rank of AB and rank of A. How to find the rank of AB? The entire matrix is AB matrix, correct? How many non-zero rows we can count? This is one non-zero row. It is also non-zero row. Look at here, each and every element is 0 in the last row. So that this is a 0 row. You have to count only non-zero rows. So only 2 non-zero rows. Since 2 non-zero rows. Now, for finding the rank of A, leave of the last column. This is matrix A. This is one non-zero row. Here one non-zero row. It is a 0 row. Here also number of non-zero rows equals 2. That is the rank of A. Same reason. Okay. Since rank of A comma B that is equal to rank of A that is equal to 2, but this is less than number of unknowns. Number of unknowns. We know that number of unknowns x, y and z 3. Here 2 less than 3. 3 that is number of unknowns. The system. That means the system of equation. The system is consistent and has infinitely many solutions. How to find the solution? To find the solutions. Consider the last equivalent matrix. Write that matrix in equation form. Okay. Here is the last equivalent matrix. First 3 rows and 3 columns. That is an A matrix. 5, 3, 7, 0, 11, minus 1. 5, 3, 7, 0, minus 11, 1. Sorry, 11 and minus 1. This is plus 11 and minus 1. Okay. (11) and minus 1. Next, third row 0, 0, 0. 0, 0, 0. Here as usually x, y, z. Right hand side matrix, we have to consider the last column of that last equivalent matrix 4, 3, 0. 4, 3, 0. Okay. Now you can multiply 5 into x, 5x, 3 into y, 3y, plus 7 into z, 7z, that is equal to 4, that is equation number 1. 0x, that is 0, 11 into y, 11y, and minus 1 into z minus z, that is equal to 3. That is equation number 2. Now last one 0x, 0y, 0z, that is equal to 0. So all 0 only, no need to write. Here we have 2 equations but 3 unknowns x, y, z. In that case what to do? We have to consider. Put z equals k. We are assuming that z equals k in equation number 2 and 1. First start with equation number 2. In equation number 2, that z has to be replaced by k. What about that k? K, where k belongs to a set of real numbers. Remember, in equation number 2, 11 y write as it is minus that z can be replaced by k, that is equal to 3. Now 11y that is equal to 3, it comes right hand side plus k. Therefore y that is equal to 3 plus k by 11. Okay. Now equation number 1 implies, in equation number 1 here it is 5x as it is plus 3y. Y, that y can be replaced by 3 plus k by 11. Finally 7 z. What is z? K. 7k, that is equal to 4. From that you have to find out the value of x. I am retaining 5x plus 3 into 3 plus k. You can multiply 3 3s are 9 plus 3 into k, 3k. 9 plus 3k by 11 plus 7k, that is equal to 4. I am retaining x alone in the left hand side, others in the right hand side. 4, it comes right hand side, minus of 9 plus 3k by 11, it comes right hand side, minus 7k. So what is the LCM? 11 is the LCM, you know. 11. Okay, put 1 over here, 1 over here. 1 table for 11, 11 times. 11 fours are 44. 11 table for getting 11, 1 time, multiply. Minus 9, minus into 3k, minus 3k. Here 1 table how many times? 11 times. 11 into 7, 11 into minus 7, minus 77k equals 44 minus 9, that is equal to 35. 35 minus 3k minus 77k, same family, add together, minus 80k divided by 11, that is a value of 5x. So 5x, that is equal to, since 5x is there, 35 and 80, which one is common? We can take 5 as common. 7 minus 16k divided by 11. Both 5 get cancelled. Now we can write x. X, that is equal to 7 minus 16k divided by 11. Now we got the value of x also. Finally write the solution. Solution: x comma y comma z, that is equal to x, that is equal to 17 minus 16k by 11, and y, that is equal to, here it is 3 plus k by 11, 3 plus k by 11, and we considered z as k. Already I told you where k belongs to R. We know what do you mean by R? R is a set of all real numbers. Uncountable numbers are there, so that it has infinite number of solutions. We can verify by considering any one value. Verification. Okay, I consider k as 0. 0 belongs to real number. No. When k, that is equal to 0, what about that x, y, z? I am going to replace k by 0 over here. If you replace k by 0, you will be getting 16 into 0, 0 only. So only 7 by 11. If you replace k by 0, you will be getting 3 by 11. If you replace k by 0, you will be getting 0 only. Right? This is x value, y value and z value. Now consider any one of the given equation. You have to verify LHS and RHS are equal. Here we have 3 equations. I consider the first equation, 5x plus 3y plus 7z. 5x plus 3y plus 7z. Listen carefully. 5, x can be replaced by 7 by 11. This is 11. Plus 3 into y can be replaced by 3 by 11. And 7 into z can be replaced by 0. 5 7s are 35 by 11. 3 3s are 9 by 11. That is equal to, what is the common denominator? 11. Add the numerator, 35 plus 9, that is equal to 44. 44 by 11, that is equal to 4. And look at the RHS of equation number 1. Here it is. That is equal to 4. Now LHS and RHS are equal. That's all. Problem number 4 is over. I will be continuing problem number 5 in the next video. Thank you, children. Sivakumar, 12th Standard Business Mathematics and Statistics. Chapter number 1, exercise 1.1. So far we have completed up to problem number 5. This is problem number 6. We are given 3 equations. For what values of lambda the system has no solution? You have to find out the values of lambda. Write the equations in matrix form. Three minus 1 lambda, 2 1 1, and 1 2 minus lambda, 1 2 minus lambda. Here x y z equals 1 2 and minus 1 in the right hand side. Consider as A, x and b. Next we have to write augmented matrix. Two matrices together. A matrix 3 minus 1 lambda, 2 1 1, 1 2 minus lambda, and B matrix. Write the first row as it is. 3 minus 1 lambda and 1. R1 no change. R2 implies. This is the first non-zero element in the first row, under which we have two numbers, both the numbers to be changed to 0. So that I am multiplying 2 by 3 and 3 by 2. That is 3 R2 minus 2 R1. in rough work. Multiply R2 by 3. 3 2s are 6, 3 1s are 3, 3 1s are 3 and 3 2s are 6. Multiply R1 by minus 2. Minus 6 plus 2, minus 2 lambda and minus 2. Six minus 6 0, 3 plus 2 5, 3 minus 2 lambda, 6 minus 2 4. Okay. Now write 0, 5, 3 minus 2 lambda and 4. Now R3 implies, even we have to change this number with the help of that number as 0. What's the number here? 1. That 3. So that 3 R3 minus R1. 3 R3 means multiplied by 3. 3 1s are 3. 3 2s are 6. 3 into minus lambda minus 3 lambda. 3 into minus 1 is minus 3. R1 multiplied R1 by minus. Just to change the sign. Minus 3 plus 1 minus lambda minus 1. 0, 7 minus 4 lambda minus 4. 0, 7 minus 4 lambda minus 4. Put equivalent. Write the first row and the second row as it is. R1 and R2 no change. In second row, this is the first non-zero element under which there is only one number, it has to be 0. For making these two numbers are equal, I am multiplying 7 by 5 and 5 by 7, right? So 5 R3 minus 7 R2. Multiply R3 by 5. 5 into 0, 0. 5 7s are 35. 5 into minus 4 minus 20. 5 into minus 4 is minus 20. Multiply R2 by minus 7. 0. Minus 7 into 5 minus 35. Minus 7 into 3 is minus 21. Minus 7 into minus 2 lambda is 4 lambda. Minus 7 into minus 2 minus 14 lambda plus 14 lambda, and minus 7 into 4 is minus 28. Okay. Now 0, 0, minus 20 lambda plus 14 lambda, that is equal to minus 6 lambda minus 21. Add together minus 48. Right over here 0, 0, minus 6 lambda minus this is minus 21. Minus 21, finally minus 48. It is in echelon form. Now write the rank of A comma B and the rank of A. Rank of A comma B first. Rank of A comma B, you have to count how many non-zero rows in AB. This is one non-zero row. It is also non-zero row. Even this one is non-zero row because we have the number minus 48. 0, even though we have two zeros, minus 48 is there. It should be considered as a non-zero row. So rank of A comma B, that is equal to 3. Since 3 non-zero rows. Given the system has no unique solution. So no unique solution means if rank of A comma B is equal to 3, a rank of A must be either 2 or 1. They are not equal. So rank of A comma B, rank of A, it should be 2 or 1. We can check. Look at that. I leave up the last column. this alone A matrix, correct? We have 3 and minus 1, so it is a non-zero row. We have the number 5, therefore it is a non-zero number. Here we have double zero, so definitely the rank of it has to be 0, then only can get the rank of A will be 2. No chance of getting rank of A as 1 because we have the number 5 here. Here the number 3 and minus 1, so definitely 2 only. So therefore the rank of A should be 2. What's the reason? No unique solution, means rank of A comma B and the rank of A are not equal, right? If rank of A equals 2 means definitely this portion, particularly minus 6 lambda minus 21, has to be 0, then only can get the rank of A as 2. So minus 6 lambda minus 21 has to be 0. So minus 6 lambda, that is equal to 21, lambda that is equal to 21 by minus 6, and lambda that is equal to divide by 3 table 2 times 7 times, what's the answer? Minus 7 by 2. That means for the value of lambda that is equal to minus 7 by 2, the system has no unique solution. So problem number 6 is over. Then I will be continuing problem number 7 in the next video. Thank you, children. Hi students, this is Sivakumar, 12th Standard Business Mathematics and Statistics, Chapter number 1, Exercise 1.1, 8th problem. Here you are given an amount of rupees 5,000 is to be deposited in 3 different bonds bearing 6%, 7% and 8% per year respectively. Total annual income is rupees 358. If the income from the first 2 investments is 70 rupees more than the income from the third, then find the amount of investment in each bond by rank method. Okay, here is the answer. Let X, Y, Z be the amount deposited in 6%, 7% and 8% bond respectively. What is given in the question? Total amount deposited is 5,000 rupees. So X plus Y plus Z, that is equal to 5,000. Let it be the first one, first equation. Second one, for the amount X, what is the rate of interest? 6%. For the amount Y, the rate of interest is 7%. For the amount deposited Z, the rate of interest is 8%. The total interest, what is given? Total interest, that is equal to 358. That is equal to 358. We have to simplify. 6x plus 7y plus 8z, common denominator is 100, that is equal to 358. So 6x plus 7y plus 8z, that is equal to, if we cross multiply, you will be getting 35,800. That's the second equation. And the third condition, listen, the income from the first 2 investments is 70 more than the income from the third. That is, income from first x into 6 by 100 plus income from second y into 7 by 100 is equal to 70 more than income from the last z, that is z into 8 by 100. Here common denominator 100, write 6x plus 7y. Here 70 plus 8z by 100. For eliminating this 100, multiplied by 100. If we multiply it by 100, 100 get cancelled, we will be getting 6x plus 7y. If we multiply it by 100, 70 into 100 is 70,000. Sorry, 7,000. Plus, if we multiply by 100 get cancelled, 8z only, right? Equals 6x plus 7y. It comes left hand side minus 8z, that is equal to 7,000. So we have 3 equations. First one, second and third. Now you are asked to find the values of x, y, z by rank method. So that I am going to write the given equations in matrix form. Matrix form. X, y, z coefficients in first equation 1, 1, 1. Right? 1, 1, 1. Second 6, 7, 8. 6, 7, 8. Third 6, 7, minus 8. Here as usual you write x, y and z. Constant here 5000. Here 35,800. At the last 7,000. As usual we consider capital A, capital X and capital B. Next step, augmented matrix. Augmented matrix. Two matrices together. First matrix 1 1 6 7 8 6 7 minus 8. 1 1 6 7 8 6 7 minus 8. A matrix over. B matrix 5000 35,800 7,000. 5000 35,800 7,000. Okay. Now we have to convert this matrix into echelon form. Put equivalent symbol. Write the first row as it is 1, 1, 1 and 5000. R2 implies this is the first non-zero element in the first row. Below which two numbers are there. We have to change them into zeros. See, 6 is there, 1 is there, so that I am writing R2 implies R2 minus 6 R1. Rough work. R2 write as it is 6, 7, 8, 35,800. R1 multiply should be multiplied by minus 6. Minus 6, minus 6, minus 6. If you multiply by minus 6, you will be getting minus 30,000. 6 minus 6, 0. 7 minus 6, 1. 8 minus 6, 2. 35,800 minus 30,000 is 5,800. So 0, 1, 2, 5,800. 0, 1, 2, 5,800. Even this number has to be changed to 0. So that R3 implies R3 minus once again 6 R1. What is R3? 6, 7 minus 8, 7,000. Multiply R1 by minus 6. Again minus 6, minus 6, minus 6, minus 30,000. Zero, 1, minus 14, 7,000 minus 30,000, that is equal to minus 23,000. Right over here 0, 1, minus 14, minus 23,000. Once again put equivalent matrix. Write the first row as it is. R1 no change. Even R2 no change. 0, 1, 2, 5,800. This is the first non-zero element in the second row, under which there is only one number. It has to be changed to 0. Very easy. R3 implies here 1, there also 1. So directly can subtract R3 minus R2. R3, that is Here it is 0, 1, minus 14, minus 23,000, same. Now R2 should be multiplied by minus, so 0, minus 1, minus 2, minus 5,800. Okay, 0, 1 minus 1, 0, minus 14, minus 2, minus 16. If we add, we'll be getting 23 plus 5, 28, minus 28,800. 0, 0, minus 16, minus 28,800. It is in echelon form. Rank of A comma B, that is equal to rank of A, correct? See, how many non-zero rows for A comma B? 3 non-zero rows. Leave up the last column. This is a matrix. Even in A matrix, we have 3 non-zero rows. Therefore, rank of A also 3. So, write the reason. Since 3 non-zero rows. Same reason here. Since rank of A comma B, that is equal to rank of A, that is equal to 3, that is equal to number of unknowns. The system is consistent because number of unknowns x, y, z, 3, correct? Consistent and has an unique solution. How to find the solution? To find the solution. To find the solution. Consider the last equivalent matrix. Write in equation form. Here is the last equivalent matrix. 111 0 1 2 0 0 minus 6. 111 0 1 2 0 0 minus 16. Here as usual x y z. Here you have tried the B matrix. Last column 5,000 5,800 5,000 5,800 and minus 28,800 minus 28,800. Now can multiply 1 into x plus 1 into y plus 1 into z, that is equal to 5,000. Let it be equation number 1. Then 0x 1y plus 2z, that is equal to 5,800. Equation number 2. Finally 0x 0y minus 16z minus 16z, that is equal to minus 28,800. Minus minus get cancelled. Therefore z equals 28,800 divided by 16. I divide here 28,800 divided by 16. 16 ones are 16, balance 12, 8. How many times? 8 times. Yeah, 8 6 are 48. Yeah, 128. Then how many zeros balance? 00. This is a rough work. That is equal to 1,800. Got the value of z. Now substitute the value of z in equation number 2 first. Equation number 2 implies y plus 2z. Z value is 1,800. That is equal to 5,800. Y plus multiply will be getting 3,600. That is equal to 5,800. Y, that is equal to 5,800 minus 3,600. Y, that is equal to how much? 1,000 8 minus 6 2 and 2,200. Now equation 1 implies x plus y value 2200 plus z value is 1800, that is equal to 5000. X, if we add, you will be getting 3000 and 4000, that is equal to 5000. X, that is equal to 5000. It comes right hand side minus 5000, sorry 4000. 5000 minus 4000, that is equal to 1000. X, that is equal to 1000. Therefore, the amount deposited in 6% bond equals amount deposited in 7% bond equals amount deposited in 8% bond equals. For 6% you have to write the value of x, that is equal to 1000, so 1000 rupees. For 7% you have to write the value of y, that is equal to 2200. 2200 rupees. And for 8% you have to write the value of z, that is equal to 1800. 1800. Just for verification, if we add, you will be getting 1000, 3000, 3200, 4000, totally 5000. What is given? Already you are given, that's the total amount deposited, that is equal to 5000. Here it is, correct? Now the problem is over. Even that exercise 1.1 completely over. You try to do the example sums. Okay, if you have doubt in that example sum, you can ask me. That's all, children. Thank you.